So in yesterday's session we have seen what are arrays, and we told that there are three types of arrays: one dimensional array, that is single dimensional array, one dimensional array. Second one is multi-dimensional array, and third one is zagged arrays. These three arrays we have seen in the previous session, and we have also looked examples in this, and we worked on the examples on one dimensional, multi-dimensional, and zagged array. Today we are going to discuss a concept called as typecasting. This is also a very important concept. So what is typecasting actually? It is a process of converting from one data type to another data type. Typecasting is nothing but it is the process of conversion from one data type to other data type. Okay, to other data type. We have seen actually convert.to in 32 for conversion of integer to the string in previous sessions, like if for example int a equal to, if we are giving an integer value, we have converted it like this: convert.to int 32, and in between console.readline was there. So this was the example for that. For typecasting, int a equal to convert.to int 32 console.readline. So this was an example for a typecasting. So when we will go for this typecasting is whenever we want to assign one data type value, that is here we are assigning the string variable to an integer variable. This is called as a typecasting. So whenever we want to convert the string value into the integer data type, okay, we will go for typecasting. So how many types of typecastings are there? Actually there are three types of typecasting. Number one is implicit typecasting. Number two is explicit typecasting. Number three is boxing and unboxing. We'll discuss in detail now what is implicit typecasting, explicit typecasting, and boxing and unboxing. Okay, implicit typecasting. First of all, we'll discuss what is implicit typecasting. So what is implicit typecasting? By default, actually C#.NET will support some of the type conversions which are called as implicit typecasting. C#.NET defaultly supports this typecasting. To implement implicit typecasting, programmer does not require to implement any special syntax except assignment operation. C#.NET supports some of the typecasting methods. Okay, some of the typecasting methods defaultly. Okay, for implementing this, actually programmer doesn't require any special type of syntax. No special syntax is required except assignment operation, that is equal to. No special data types or assignment operations is required. No special syntax is required to perform this task except assignment operation, that is equal to operation. Okay, is equal to operation. To implement it, except is equal to operation, that is assignment operation, and I'll give you a table which describes the possible implicit type conversion type, which gives the possible type implicit typecasting conversion details. This is actually from, and it is converted to. Okay, let us see it now. We have discussed these data types. S byte, if you remember, we have discussed these data types. It can be converted to short, int, long, float, double, and decimal. Make a note of it, because in future while type conversion you will be knowing it in detail. Okay, double and decimal. So S byte can be converted to like this, and byte can be converted to short, u short, int, u int, long, u long, float, double, decimal, float, double, decimal. Okay, byte can be converted to all these types, and short can be converted to int, long, float, double, and decimal. Short can be converted to int, long, double, decimal. And next is u short. At most we will not use this u short actually. We will be dealing with byte short actually. Okay, u short. It can be converted to int, u int, long, u long, float, double, and decimal. Int, u int, long, u long, float, double, and decimal. Like this. And now integer value, int can be converted into long, float, double, and decimal. These are the type conversion methods. Int can be converted to all these data types. Maximum we will deal with the integer only, long, float, double, and decimal. And next is u int. U int can be converted to long, u long, float, double, and decimal. Long, u long, float, double, and decimal. Okay, these are the data types which it can be converted. And next is int, u int. Next is long. Long can be converted to float, double, and decimal only. Long can be converted to float, double, and decimal. Next is u long. U long can be converted to same, float, double, and decimal. Okay, and the float can be converted only to double. That's it. So these are the data types which can be converted to all these relevant data types. S byte can be converted to these data types, and this data type byte can be converted to these data types. Okay, and short in a similar fashion, short, u short, this short, u short, int, u int, long, u long, float can all be converted to these data types only. So, and next we didn't discuss about char. Char can be converted to u short, u int, int, long, float, double, u long, float, double, and decimal. These are the main data types: float, char, int. Okay, and string. String can be converted only to object. String can be converted only into the object. Okay, so string can be converted only into the object data type. Object is the main class for all the data types. From this only, this is the base class actually. Okay, so we will see an example now to convert integer to long. How integer can be converted to long. So make a note of all these data types. This relevant data type can be converted only into these data types. Okay, and in real time actually we'll be dealing with only these data types: int, long, float, char, and string. Okay, string is user defined data type. This is a class actually, and all these are provided as structures. We have seen that skeleton view in the previous sessions how it will be. So let's see now an example how to convert an integer data type to long data type. Let's assign a value int I is equal to 10. Let's see that. And long, let's take long j equal to I. That means I am giving the I value, I variable to j variable. In I variable I have stored 10. Now I am giving it to long. Let's see console dot write line now I will print the j value, because in j I value is there. I want to print the j value. J value is, just concatenate j value here. Okay, j variable. This console dot read line is there. Just check it. You will be getting the same value of 10. Press F5. We will execute the program and check it now. We will be getting the value of 10, that's all. So j value is 10. That means in j value I value is stored. So this is called as implicit typecasting. That means we can convert one variable type into another variable type. Here we are converting long variable type into integer variable type to the long variable type. And example for implicit typecasting to convert from character to int and double. We can convert character to int and double also. Let's see that example also. This is another example. Char should be enclosed in single quotations. Let's keep it a some value. Now int I equal to C. Okay, int I equal to C. That means in integer value I am putting the character value. Console dot, I just want to print the value. Console dot write line I value is int I value is. Now I am putting the value of I. Just concatenate the I variable here because it is carrying the value of C. actually, and now I am giving it to double again, double D equal to C. Okay, console dot write line, double D value is plus D, like that. Like that, how many values you can assign? You can assign that. See, check it. First of all, what I have done is I have taken a character variable C, character data type I have taken, and in C I am giving a value of A. That value, that variable C, I am giving it to integer value. So I am converting the character data type to into integer data type. Console dot write line, int I value is I. After that, I am giving again this C value to double D, to different data type double. So now the double value is double D value is D. That means I have to get 2 A's now in the output. Okay, just press F5. See, I am getting the value as it is ASCII. That is why it is showing 97. That means this A value is value of 97 in ASCII code. So int I value is 97 and double D value is 97. It is showing the value. It will not show the letter A, but it shows the ASCII code. Okay, so this is how we convert the implicit type conversion. We will perform the implicit type conversions in this way. And next is explicit typecasting. Explicit typecasting. Let us see explicit typecasting. What is explicit typecasting, and when we will go for explicit typecasting? Whenever we are assigning one type value into another type, it is similar to implicit typecasting only. Whenever we want to convert one data type variable into another data type variable, we will go for implicit typecasting actually, and then again we have to go for explicit typecasting. While implementing explicit typecasting, programmer has to follow some special type conversion syntax. Actually, programmer has to follow special syntax here. In previous operation, only is equal to is enough, because see here, only is equal to, that is assignment operation, is enough. Whereas in explicit typecasting, programmer has to follow some special syntax here. Then only he will be able to convert one data type into another data type. In C#.NET, actually explicit typecasting we can implement by using 3 methods. First of all, we will see whenever why and when we will do explicit typecasting. Answer is whenever we are assigning one data type to other data type, we will go for one data type, we can call it as value, one data type value to other data type value. Which is not possible by implicit typecasting. If it is not possible by implicit typecasting, then only we will go for explicit typecasting. Which is not possible by implicit typecasting, then we will go for explicit typecasting. Then we will do explicit typecasting. That's it. Then we will do the explicit typecasting. How can we do it? By using a special syntax should be followed for this. A special syntax should be followed for this explicit typecasting. In C#.NET, actually we can perform the explicit typecasting by 3 techniques. Number one is, three techniques are there to perform this. Number one is C++ style. C++ style of typecasting technique. C++ style of typecasting should be done. Second way is parsing technique. And third way is converting technique. Just as convert.to into 32 we have discussed. Converting technique. Okay, these three ways we can do explicit typecasting. One is C++ style of typecasting, second one is parsing technique, and third one is converting technique. So how we will do this C++ style of typecasting? A special syntax should be followed for this. I will show you the syntax. This is the data type to be converted. To which data type we'll see? To data type, any data type. To what is a variable is equal to again to data type from variable. That means what data type it has to be converted we have to give here, and what variable we will give here is equal to assignment operation to data type and from variable, from which variable it has to be converted, followed by a semicolon. This is how we'll convert it. We'll do it here in the example. I'll show you this. I'll show you an example for this now. This is a second method, parsing technique. We'll discuss that also. Now in example I'll show you how to convert it. Just comment this. So let's give a integer I equal to 100. Okay, and now I want to convert it to byte. Byte b equal to byte of I. Byte of I. So we need to display it console dot write line byte value is byte b value is, now 100 should be the answer, plus b variable, because we are displaying b. So in this way we can convert it. If you closely observe it, this is the to data type, that means byte here, the very first thing byte, and space to variable, we are giving a variable. After that is equal to we are giving again the data type to data type, okay, to be converted. At last I is there. I means it is a from variable. We are converting from that variable to this variable. This is the syntax which I was discussing. To data type space to variable is equal to data type from variable. Okay, in this fashion we can convert it. This is called a C++ technique. Okay, execute it and check it. Now we should get the double values 100. See, byte b value is 100 here. Byte b value is 100. Okay, like this. So this is called as explicit typecasting. It's called a C++ style of typecasting technique. Okay, and second one comes parsing. We haven't seen this parsing. This is also very important for type conversions, to convert the one value data type to another data type. Parsing. To implement parsing, we will use a predefined method called as parse. Programmers have given us a method called as parse to implement parsing. What is parse? It is a predefined member method of every primitive data type structure. It is nothing but a predefined member of every primitive Primitive data types we have discussed. Data type structure, not general data types, primitive data type structure. Parse is nothing but it is a predefined member of every primitive data type structure. 4 data types will be coming under this primitive data types. Okay, so parse is nothing but it is a member of this. Okay, predefined member. Parse is nothing but it is a predefined member of every primitive data type structure. Parse method will accept string value and it will convert string value into calling data type, and that converted value it will return. What does it do means, parse method will accept string value and it converts string value to string value into calling data type value. That is the specialty of parse. It accepts the string value actually and it converts the string value into calling data type value. That means the opposite data type to be converted. It string value into calling data type value and returns that value. It accepts only string value but it converts the value into the opposite data type value and returns that value. That is the importance of parse method. Let us see it in an example clearly. You will get a clarity. Just comment this. So let's see an example how to do it. Console dot write line enter your ID. Let's enter our ID. Okay, and int, I am giving it int. Again I am converting int dot parse. Check this method, int dot parse. Okay, console dot, its return type will always be string. It converts the value into integer value now and returns the integer value. Again console dot write line enter your weight. Let's enter the weight. Float, I want to convert to float now. Float, take it as weight only, variable name. This is a meaningful name. Float dot parse, now it converts the given value into float and its return type is string. Now it converts the string value to float value. That is the advantage of parse function. Okay, and display to the user a message, console dot write line your ID is. Okay, and ID, concatenate these variables here, and console dot write line your weight is plus weight. That's it. And now execute this. Enter your ID, given ID 111. Enter your weight. You need to give it in float value. Weight 75.550. See, it is giving the values. Your ID is 111 and your weight is 75.5. So it is converting the integer value and float value here and returning the values. That's the importance of parse function. In this way, it converts the, here actually the return type of the parse is always a string, but it is converting the string value to the given data type value. Given data type value, we want to convert it into integer here. Here also, weight means it is actually parse function means I told you it is a string value. Here it is converting the value to the given data type value. So float value. Okay. So this is the importance of parse function. and this is the way how we can do the type conversion using this second method, parsing technique.